প্ৰিয় শিক্ষাৰ্থীসকল, কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক দৃশ্য শ্ৰাব্য অনুষ্ঠানটিলৈ আপোনালোকক স্বাগতম জনাইছো। স্বয়ং প্ৰভা DTH চেনেল 20ৰ যোগেদি শিক্ষাৰ্থীসকলৰ অধ্যয়ন কাৰ্য অধিক মনোগ্ৰাহী আৰু ফলপ্ৰসূ হোৱালৈ লক্ষ্য ৰাখি বিভিন্ন বিষয় সামৰি আমাৰ এই বিদ্যায়তনিক অনুষ্ঠানটি সজোৱা হৈছে। আহকচোন প্ৰিয় দৰ্শকসকল, আমাৰ আজিৰ খণ্ডটিৰ মাজলৈ আগবাঢ়ো।
Now we discuss about the decoder combinational circuit. So a decoder is a combinational logic circuit that receives coded information of n input lines and converts them to maximum of 2 to the power n unique output lines. So decoder is functions just opposite to a encoder, and the decoder outputs will have less than 2 to the power n outputs when some of the n bits decoded informations are unused or are do not care combinations. Now we see the block diagram, truth table and logic circuit of decoder. So now this is a block diagram of n to 2 to the power n decoder. Here n numbers of inputs, then it decodes to 2 to the power n outputs. If n is 3, that means 3 inputs, then output will be 2 to the power 3 equal to 8. So 8 outputs, it is marked as O0, O1 to O7. So it is a 3 into 8 decoder. Now we see the logic circuit and the truth table. So since there is a 3 inputs, so we have given A, B, C. These are the 3 inputs and outputs are O0, O1, O2, O3, O4, O5, O6 and O7. So for the 3 inputs, what are the combinations? First is 0, 0, 0, then 0, 0, 1, 1, 0, 0, then 1, 0, 1, 1, 1, 0, and last is 1, 1, 1. So when all the 3 inputs are 0, then the output O0 is selected. So this is 1, and the rest of the outputs are 0. When the input 0, 0, 1 is selected, O1 output is 1. Others are 0. For the third case, O2 output is selected. For the fourth case, output O3 is selected. And for the last combinations, when all the inputs is high, then output I7 is high. So this is the truth table for 3 into 8 decoder. So these are the inputs and these are the outputs. So now we see the logic diagram for 3 into 8 decoder. So now since there are 8 outputs, 8 numbers of n gates will be there, and the 3 inputs A, B, C are the 3 inputs, and it's complemented with by using the NOT gate. So for the first combinations 0, 0, 0, that means when all the 3 inputs A, B, C are 0, that means this one and this one 0, then output of the first AND gate, that is O0, is high, it is selected. For the second case, 0, 0, 1, that means A is 0, A is 0, B is 0, here B is 0, then C is high. So this is the high line. Then for the third case, B is high, A and C is low. So A is low, B is high, and C is low. For the fourth, B and C is high, A is low. So A is low, B is high, and C is high. So this is the C is high. For the next case, when output O4 is high, then the A is high, then the rest B and C is 0. So A is high, so this one is high line, and B and C is low. Then A and C is high. So here A is high, B is low, and C is high. Then for the sixth output, here the combination is A and B is high. So this is high A. Then B, this line is high, and C is low. So this is the C low line. And for the last AND gate, that means for O7 output, all the three inputs are high. So this is A high line, then B is high, and C is high. So this is the logic circuit for 3 into 8 decoder. So 3 means 3 inputs A, B, C, and 8 means 8 decoded outputs. So O0 to O7. So first you draw the truth table by using these combinations 0, 0, 0, 0, 0, 1. So all these 8 combinations are there, and the 8 outputs O0 to O7 are given here. That means the output, only one AND gate output is high at a time, and the rest of the other output of the AND gates is 0. So this is a 3 logic circuit of 3 into 8 decoder. So the function of decoder is just opposite to the encoder. So a 3 to 8 line decoder circuit can be used in binary to octal conversion, and the decoder is also used in some code conversion, for example BCD to 7 segment decoder. And another use of a decoder is that it can be used to implement any combinational logic circuit. So we have discussed about the 3 to 8 decoder. Next we see the combinational circuit of adder and subtractor. So first, adder means there are 2 types of adder. One is half adder and the other is full adder. And first let us see a half adder. Half adder is a combinational circuit that performs the addition of 2 bits. So in this logic circuit, 2 binary inputs and 2 binary outputs are required. Now let us see the block diagram of a half adder. So this is a half adder. So 2 inputs, 2 outputs. Suppose A and B are the inputs and S and C is the output. So here the output S equal to A B bar plus A bar B, and C is also known as carry. S is known as sum and C is known as carry. So carry is A into B. Now from this sum equations, the truth table will be A, B, then S and C. So the truth table of the half adder for the two inputs A, B, that means 0, 0, 0, 1, 1, 0, 1, 1. So these are adder, so 0 and 0 is added. So when 0 plus 0, we get a 0. 0 plus 1, the output sum is 1. 1 plus 0 is 0, sorry, 1, and 1 plus 1 is 0, carry 1. So other carries 0. Now the logic circuit of a half adder is for two inputs, that is A and B, then two AND gates, and the output of the two AND gates are added, so there is a one OR gate. This is the S input, S output, and the other is C, carry output. So here the input is A, then A naught, and B and B naught. So for the first case, when 0, 0, that means A0 and B0. For the second, 0, 1. So 0 when output is high. So sum is when sum is high, when the combination is 0, 1. So we have to put 0 and 1. For the next case, the sum is high when the input combination is 1, 0. So this is 1 and this is 0. So output is A B bar plus A bar B. And in the next case, the C carry, it is A into B. So A is A high, B high, carry is 1. Here A high and B high. So this is a half adder logic circuit. So what is a half adder logic circuit? Half adder logic circuit is a combinational logic circuit which added 2 bits and it gives 2 outputs. 2 bits means A and B, and S outputs are sum and carry. So sum equations is A B bar plus A bar B, and carry, it is the output is A into B. So in the truth table, for 2 bits, the 4 combinations are there, and the output sum is high when any of the input is high, and when both the inputs are equal, that means either it is 0 or it is 1, then the sum output is 0. And for the carry output, when both the inputs are 1, then the output is high. So this is the logic circuit for half adder. Next we will see a full adder combinational circuit. So now we will discuss about the full adder combinational circuit. A full adder combinational circuit is a circuit which added 3 bits binary signals or binary inputs, and there are 2 outputs, sum and carry. It consists, the 3 input consist A and B, which we have already seen in case of half adder, and the third input is the carry, which is coming from the lower order bits when multi-bit addition is performed. So in case of a full adder, 2 of the input variables, suppose A and B, represents the 2 significant bits to be added, and the third variable, that is C, which is represent to carry from the previous lower significant position. and the output variables, that is S, which gives the value of the least significant bit of the sum, and the output variable C, which gives the output carry. Now let us see the truth table and the logic circuit of a full adder. So here full adder, this is a block diagram, 3 inputs A, B and C and 2 outputs S and C, sum and carry. The outputs sum, it is represented as the relation by this, that means A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C, and the equation of the carry, that is C, is A B plus B C plus C A. And here the truth table, here's 3 inputs A B C and the combinations, it is written like this. And for the sum, when A 0 0, that means 0 plus 0 is 0, again 0 plus 0, it is 0. Then for the next, 0 plus 0 is 0, and 0 plus 1, it is 1. Then 0 plus 1, 1, 1 plus 0, it is 1. Then the 0 plus 1, it is 1, and 1 plus 1 is 0, carry 1. So here the carry is 0. And for the fifth combination, 1 plus 0 is 1 and 1 plus 0 is 1. And 1 plus 0 is 1, 1 plus 1 is 0, carry 1. Then 1 plus 1 is 0, carry 1, 0 plus 0 is 0. Then 1 plus 1 is 0, carry 1, 0 plus 1 is 1. So this is the outputs of the full adder. What we have seen here, that when any of the input is high, that is 1, the output sum is high, and when any of the 2 inputs are equal, that means 1 1, the output is low. Now we draw the logic circuits. Here for the first is sum S. First we have given 4 AND gates. Then because 4 terms is there, and 1 OR gate. So for the first combination 0 0 0, sum is 0. For the next, when sum is high, for the combination 0 0 1, that means A is 0 0 and C is high. For the next case, when 1 is high, A is 0, B is high, C is 0. A is 0, B is high and C is 0. For the next, this combination, A is 1, B and C is 0. A is 1 and B and C is 0. Then for the last combinations, all A, B, C are 1. So here this is A high, B high and C high. So this is the logic diagram for the S output, and for the C output, that is carry, when it is 1, when the combination is, so this AB plus BC plus CA, these are the A, B, C. So first case, when it is high, that is BC, so BC. Next it is high, that means AC, so AC. Then it is high, AC, then BC, AB, so AB. So this is the circuit for the outputs carry C, and this is the circuit for the output sum. So now dear learners, in today's class, what we have discussed till now, first we have discussed the combinational logic circuit. What is a combinational logic circuit? It is a circuit which consists of some interconnected set of logic gates with some input variables and output variables. And some examples of combinational circuits we have discussed. First, we have discussed a multiplexer. So a multiplexer is a combinational circuit where the binary information is selected from one of the to the power n input lines, and it is transmitted to a single output line. So if the n is a number of selection lines, then that 2 to the power n combinations will be there. So multiplexer is also called many to one. Next we have discussed the demultiplexer. So in demultiplexer we have discussed the 1 to 4 demultiplexer. So it is a 1 to many. And after that we have gone through a encoder, which is a combinational circuit which generates the binary code for the two n input variables. That means 2 to the power n into n encoder. Next we have seen a decoder combinational circuit which receives codes information on a n input lines and transmit them to maximum of 2 to the power n unique output lines after conversion. And next we have discussed the adder. So there are two adders, one is half adder and a full adder. In the half adder, it is a combinational circuit that adds 2 bits, and next is the full adder which is used to add 3 bits. So in the next class we will discuss about the subtractor, and then we go to our next unit, that is sequential logic circuit. So in sequential logic circuit, the output depends on the input as well as the past outputs. So in sequential circuit, a memory is used. Hello dear learners, I am Antara Baruah, Assistant Professor, Discipline of Electronics. In this video class, we shall discuss about some sequential logic circuits, which is included in the digital technique paper of first semester BCA program. In our previous video class, we have discussed about the combinational logic circuits. We came to know that all the digital circuits are categorized into two types. One is combinational logic circuits and the other is sequential logic circuits. In combinational logic circuits, at the output at any instance depends on the input at that instance. We have already discussed about the encoder, decoder, multiplexer, demultiplexer, adder, all these combinational logic circuits. Today we shall also discuss about the subtractor before going to the details of the combinational logic circuits. So the subtractor, similar to the adder, the subtractor also classified as two types. One is half subtractor and other is the full subtractor. Now let us first discuss about half subtractor. We know the rules of binary subtraction as 0 minus 0, it is a 0. Then 0 minus 1, it is 1, that means 1 borrow. Then 1 minus 0 is 1, then 1 minus 1 is 1. So this is the subtraction rule, in binary subtraction rule. So in case of half adder, first let us see the block diagram of half adder. It has two inputs, suppose A and B, and two outputs, that is DI and B0. So this is a half subtractor. So what is DI? DI is the difference output and B0 it is the borrow output. And if we see the truth table, suppose these are the inputs A and B and outputs are DI and B0. This is the difference and this B0 is the borrow. So for the two inputs the four possible combinations are 0, 0, 0, 1, 1, 0, then 1, 1. So from this difference binary subtraction rule, so difference for 0, 0, 0, 0 is 0. So there is no borrow, so borrow is 0. For the second case, 0 minus 1. So 0 minus 1, the difference is 1 and there is a 1 borrow, so it is 1. For the third case, 1 minus 0, that means 1 minus 0, difference is 1, so it is 1. No borrow, so 0. And for the fourth combination, 1 minus 1, the difference is 1 and the borrow is 0. So this is the truth table for half subtractor. So next we shall see the logic circuit for the half subtractor. So two gates are used. So this output is DI and this is the B0. So two inputs A and B. So these are the two inputs A and B, and the inputs of the AND gate, that is where the output is B0, the inputs are A bar, that means a NOT gate is applied, and another is B. So what are the Boolean expression for the half subtractor? For difference output, the Boolean expression is similar to the half adder that we have already discussed. So this is the expression for DI, that means difference output, and for the other output B0, A bar dot B equal to B0. So this is the Boolean expression for the borrow output. So till now what we have seen, first we have see the half subtractor. So in half subtractor there are two inputs, suppose A and B, and two outputs, one is difference and other is the borrow, and this is the truth table for the half subtractor, and this is the logic circuit diagram for the half subtractor. So now this is the block diagram of full subtractor, and this is the logic circuit diagram for full subtractor. In case of full subtractor, there are 3 input bits and 2 output bits, similar to the full adder. Here the 2 input bits, that is A and B, means one input is subtracted from the other inputs, and the third input is a borrow of the previous stage. That means borrow from the previous stage, that is the third input for full subtractor. And there are 2 outputs, one is difference and other is the borrow output. Now let us see the truth table for full subtractor. There are 3 inputs, that is A, B and other is the borrow input. That means it is the borrow of the previous stage. And the 2 outputs, that is DI, difference, and the borrow output. So for the 3 inputs, the 8 possible combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, then 1, 1, 0 and 1, 1, 1. So now let us see the difference in output. So first, all are 0, so difference is 0. There is no borrow, so borrow is 0. Next, 0 minus 0 is 0, then 0 minus 1. So here difference is 1, borrow is 1. Next, 0 minus 1. From the law of binary subtraction, 0 minus 1 is 1, then 1 minus 0 is 1. So here 0 minus 1, there is borrow 1, so B output is 1. Next, 0 minus 1, that is difference is 1, borrow is 1. So borrow 1. Then 1 minus 1, that is 0, so difference is 0. Next, 1 minus 0, that is 1. Again 1 minus 0, that is 1. So borrow is 0. Next, 1 minus 0, that is 1. Again 1 minus 1 is 0. So borrow is 0. then 1 minus 1, that is 0, and 0 minus 0 is 0. So borrow is 0. And the last case, that is 1 minus 1 is 0, then 0 minus 1 is 1 and borrow 1. So this is the truth table for full subtractor. Now we have discussed about the subtractor combinational circuit. Here the full adder, there are in the logic circuit there are 2 half adder circuits are there. So this is one half adder circuit and this is the another half adder circuits. As there are 3 inputs, one is A, B, another is borrow input, that is from the previous borrow. And for the first half subtractor, the output difference output is applied to the input, and the borrow output, these are added by using a OR gate to get a final borrow output.
ইমান সময় আমি স্বয়ং প্ৰভা DTH চেনেল 20 যোগে সম্প্ৰচাৰিত কৃষ্ণকান্ত সন্দিকৈ ৰাজ্যিক মুক্ত বিশ্ববিদ্যালয়ৰ বিদ্যায়তনিক অনুষ্ঠানটিৰ আজিৰ খণ্ডটি উপভোগ কৰিলো। এই বিদ্যায়তনিক অনুষ্ঠানটিৰ জৰিয়তে শিক্ষাৰ্থীসকল নিশ্চয়কৈ ভালেখিনি উপকৃত হৈছে। পুনৰ আন এটি বিষয় লৈ আমি আপোনালোকৰ মাজলৈ আহিম। নমস্কাৰ।